Alright, in this video we're going to talk about a few scatter plots and best fit lines, also known as trend lines, and we're going to use those to make predictions and just talk about some of the data that we're looking at. So as you can see here, we are talking about blood pressure compared to age, where the y-axis is the systolic blood pressure and the x-axis is the age. And notice the little squiggly lines here, they're skipping a big range here, and we're start going from 0 and skipping all the way to 90. So the scatter plot shows the systolic blood pressure of people of several different ages. The equation represents the linear model for the stat. It's y equals x plus 95, where x is the age in years. It says according to the model, how much does the systolic blood pressure increase for each year of age? Basically what it's asking for is the rate, and mathematically that is the slope. And if you look at this equation and compare it to y equals mx plus b, you can see the m is the number next to the x, and we don't see it, but it's there. It's the number 1. Alright, so to answer that question, 1 millimeter of mercury per year. That is the rate. The rate is 1. Alright, so notice the slope. It goes up 1, right 1, up 1, right 1, up 1, right 1. According to the model, what is the systolic pressure of someone who is 42 years old? Okay, so we could kind of get an estimate by looking at the graph, but it doesn't go right at 42. So what we're going to do is put 42 in for x in the equation. Y equals 42 plus 95. Notice that went in for the x value. And then we get 137. 137. There we go. So that answers that question. Alright, let's look at another one here. This time it's monthly sales, where the y-axis is the sales in thousands of dollars, and the time is over months. Alright, so it says an employee compiled sales data for a company once each month. The scatter plot shows the data, the sales in multiples of 1,000 for the company over time. Here's the equation. 0.94x plus 12.5. According to the model, how much do the company's sales increase per month? Again, it's asking about the rate. And if you compare those to y equals mx plus b, we see the m number is 0.94. Now that's 0.94. However, in thousands per month, we would have to multiply that by 1,000. And then that equals $940. So to answer the question, each month the sales increase $940. According to the model, what will the company sales be after 40 months? So we will plug the 40 in for x, so we get 0.94 multiplied by 40 plus 12.5. Alright, 0.94 times 40 gives us 37.6. See if we can fit this all in here. 37.6, and we need to add that to 12.5. That comes out to 50.1, but we are multiplying by 1,000. So at 40 months, the company's sales will be $50,100. Let's look at one more. Pizza sales. The y-axis is the average number of pizzas sold nightly, and the x-axis is number of coupons. So this company wants to compare the coupons to the average number of pizzas, and if the more, to see does the trend right, if the more coupons they issue, well, the more pizzas they sell. According to the model, yes, they do. And the model is y equals 3.4x plus 43. Think of it as mx plus b, where m, the slope, the rate, is 3.4, and the starting amount was 43. According to the model, how many pizzas are sold for each additional coupon issued? So x is the number of coupons. For every one coupon, 3.4 pizzas are sold. And this last question, according to the model, how many pizzas will be sold nightly if they issue 15 coupons? That means you plug in 15 for X, and then add the 43. And then if we do 15 times 3.4, we get 51. So we're at 51 plus 43, and we get 94. Alright, so according to the data, if they have 15 coupons issued, they will sell 94 pizzas.